if it's number 1 on worksheet 2, if f prime is cosine of x cubed, f of 0 equals 2, find f of 1. So it gives us f prime. It asks us questions about f. So how do we get from f prime to f? That would be the antiderivative. So we're going to do the antiderivative of f prime. And we'll need to use the x values that it gives us, 0 to 1. Be f of 1 minus f of 0. I'm trying to think, do I want to go to the calculator first, or do I want to do algebra first? It doesn't really matter. I'm going to add f of 0 to the other side. So f of 0 plus the integral from 0 to 1 of f prime of x dx equals f of 1. F of 0 is 2. They gave me that one. Alright, the antiderivative of cosine of x cubed. I have no idea, but my calculator does. So math 9 is the antiderivative. And remember, you want to get a calculator that does the nice format like that. Otherwise, you end up having to know how to type things in. So 0 to 1 cosine of x cubed dx. So that's the area under cosine of x cubed, but I don't know what that is. Let the calculator do. Uh-oh. Got to be in radians. I got a number that looked really close to 1, which is what made me suspicious. Let's try that again in radians. That's still kind of close to 1, but always in radians in here. So is that my answer?
No.
No, I got to do the plus 2. So 2.931. Oh, 932.
Or you could truncate.
Or you can truncate, either one. By the way, side note, since we have time today, you can see this on the graph. If you want to integrate on the graph, cosine of x cubed. So go to the graph, type in cosine of x cubed. Yeah, who knows what that is?
Speedy, that's what that is.
I only really want 0 to 1, so I guess I'll go 0 to 3. Negative 5 to 5 is plenty to see.
Seems it goes faster.
And we want the integral from 0 to 1. So second calculus gives us some calculus options. Number 7 is the antiderivative. And then it asks you for the limits. So the lower limit is 0. The upper limit is 1. And then what's nice about it, I mean, it gives you the answer, but what's nice is it shades it in. So it's kind of reminding you of, hey, you just found the area under that curve from 0 to 1. If you did it that way, you'd have to remember to put plus 2 on there. But some people like doing the graph because it shows them the picture of what they're doing every time. Other people are like, I don't need to see a picture. I'm just going to type it in like that. Either way is fine. Skip down to number 5. Water flows into a tank. So probably positive if we're thinking about volume here. At a rate of dW dt. That equation, where dW dt is measured in gallons per hour. That makes sense. W would be gallons, time is an hour, so gallons per hour. If there are 150 gallons in the water, of water in the tank at time 0, how many gallons of water in the tank when t equals 24? Okay, so it gives me dW dt,
Which is f prime.
which is w prime,
Or, yeah.
and ask me for things about w. So I need to antiderivative w prime to get things about w. What t values should I use? 0 to 24. So w of 24, which is what they're asking for, minus w of 0, which they gave us. So very similar to number 1, we just have a word problem set up. So I'm going to stop there, or pause there, and see if you can take it from there. This is a calculator problem, or
It doesn't say no.
it doesn't say no calculator. You could do it without a calculator because those aren't terrible, but use a calculator. So use a calculator and see if you can figure out what w at 24 is.
0.36.
357.36.
Did you make sure it was a negative t squared?
A couple of things about that. The first time I did this, I really wasn't paying attention, and I got an answer of negative, and I thought that doesn't seem right. I can't have a negative amount in the tank. And
Because it was a plus.
yeah, I spotted my errors, like, oh, there's not supposed to be a minus sign there. So let me change that to a plus, and then I got a fraction. I didn't really want that either. 357.36, which I think makes sense. We started with 150, we added a bunch, so we ended with more than 150. So I guess the nice thing, maybe the only nice thing about word problems is usually you can know if your answers make sense. I shouldn't have a negative amount in a tank. I should have more than I started with. So,
Unless somehow the tank has collapsed.
although you have to be careful, you could have less than you started with if this thing was draining,
Yeah.
in which case you have to be very careful about into and out of. So if it had said out of, then I would have to really be careful about the signs on this thing. Let's skip ahead to number 8. The graph of G prime, so that we're not trying to trick you on what we're giving you. It tells you it's the graph of G prime, it's labeled as the graph of G prime. Find G of 6, somebody is going to tell me that G of 6 is 2. But that's not right. G prime of 6 is 2, but that's not what we're asking.
Yeah.
Given that G of negative 2 equals 5, find G of 6. So they gave me G prime, and they're asking about G. So if they give you G prime and they're asking about G, what do you have to do? Take the antiderivative. The antiderivative of G prime will get me something with G.
G of 6 minus G.
And now I need to be careful about, is it a plus C problem or is it a definite problem? Well, it gives me some values, so negative 2 to 6 would be G of 6 minus G of negative 2. Well, how can I find the antiderivative of G prime when I don't have an equation? Like that last one I had an equation, I'll let the calculator do the work. How am I going to find this antiderivative?
Geometric equations.
And so what am I looking at? What's the antiderivative the same thing as?
The area.
The area. So again, you always have to hold both of those things in your brain. It's the antiderivative, but it's also the area. And on this problem, the only way to do it is with the area. So I want the area from negative 2 to 6. So let's, we're going to have to break this up into pieces here. So from negative 2 to 1 would be that triangle. Let's see, 1/2 base times height, 3 times 3 over 2, 9/2.
Couldn't you make the The one from 3, like y value 3 to -2, like that triangle.
Make this triangle?
Yeah.
But no, because it always has to be relative to the x-axis.
Oh, okay.
So when it goes below, I need to make that a separate triangle. What's going to be different about this triangle?
It's got 2 different sides.
Yeah, it still has a base and a height though. 1, 2, 3 times 2 is 6.
3.
So 3. But that's not exactly right. It's negative because it's below. So the area is 3. And so some people will label it 3. But when you come over here to do the antiderivative, it needs to be -3. And I think most people would label it -3, knowing that, yeah, you really can't have a negative area, but I'm not looking for area. I'm looking for antiderivative, so I'm going to label it -3. And then lastly, a quarter circle. So pi r squared over 4. But that was kind of nice because the r is 2. So that area is just pi. So my antiderivative, not from an equation because I don't have the equation, but from my picture, from my geometry, is 9/2 minus 3 plus pi equals g of 6. And actually, let's just plus. Well, it's not a safe stop yet until I add g of -2 to the other side.
Yeah. 5.
So 5 plus. And then it's a safe stop. Yeah, you could clean that up a little bit, but
Who wants to?
we don't want to do that. Leave it as is. Okay, so today's assignment, and I guess tomorrow's assignment as well, is worksheet 2. So work it, some of it tonight. You can work on it tomorrow during class if you're not really interested in